Alright, hey guys, this is geometry for April 13th, Monday. So I hope y'all had a good weekend and everything. So today is going to be review for your test. So I'm just going to do the brief review right now and then go ahead and let y'all take the test since you can use your book and all that good stuff. There's no sense wasting extra days reviewing when you have all the material there with you. So the first thing is a large portion of this test is just definitional, which should make it an easier test simply because you do have the definitions right in front of you. And so to do true false on that, there should be no excuses because you have the information. You just need to dig back through it and make sure we're keen on it. So you need to know basically what a transformation is. You need to know about the geometric figures before the transformation, what it's called before and after. You need to know about the symmetry. You need to know about the compositions of the rotations themselves. So when I reflect it once, when I reflect it twice, when I reflect it 3 times, whatever, you need to know what those actually come together as. You need to know your definitions of dilation and your isometry definitions about what makes an isometry and what are the properties under there. So we've covered all of this. It's also in your book. So make sure you just get that information and you have it done. So that's the first portion. The second portion is actually doing the reflections, translations, and dilations. Then there's one on the colliding balls, and then there's one on the symmetry portion. And so to get us started, I'm just going to go ahead and go through the reflections, translations, rotations, and dilations. And so for a reflection, remember the key thing with a reflection is it has to, basically you're trying to find the 90-degree line, the line that intersects the line of reflection at 90 degrees, so a perpendicular bisector, and it's going to be the same distance on each side. And so all we have to do then is figure out what line would intersect X at a right angle, and then measure the distance from A to that line, and then measure the distance from that line out to find our prime. Remember the image we start with is called the pre-image. The image we get afterward, our actual answer, is called our image. And we use the prime tick marks to denote the translation or reflection. So I'm just going to take A, and I'm going to get a right angle to X, and I'm going to measure that. And so if it was 2, then I would measure from X out 2, and that would give me my A prime point. So that's where it's a right angle. So then I would measure out 2, and then that becomes my new point. So my new point would be right there. That would be A prime. B, the same way. You go from B to the line at a right angle, and then measure that distance, and then go that distance out on the other side of the line, continue on the right angle line. And so B to the line at a right angle is there. If I say that was 5, then I'm going to measure out 5, and then that becomes my B prime. And so that's how it's going to orient itself. So that is reflecting the point A and the point B across X. Okay, to translation is just basically 2 reflections. The difference between a translation and a rotation, remember, is that translations is done about parallel lines, whereas rotations are done about lines that intersect. And so for translations here, we're going to reflect it over X, then we're going to reflect that over Y. And so again, you go from A to your line at a right angle. And so if that was 3, then we go from A out 3, and that becomes our A prime. And then I would go from B to my line. If that was 6 to the right angle, then I would go from out to here, and that would be my B prime, 6. So the thing is they're the same distance, and they are intersect that line at a right angle. So then, to do the next reflection, I'm going to reflect my A prime across this line. So if I do that, and it wound up being 5, then I would go out 5, and that would be my A double prime, and then B to the line at the right angle, that was 4, then I would go, say
come out and do B double prime.
And so basically what happened is you just translated it.
So that was 4, that was 5.
And so basically you just translated it across. And now you end up with the exact same thing, just in a different portion of space. And so basically for a translation, just 2 reflections, parallel lines. For a rotation, you do 2 reflections, but you do it about the lines that intersect. And so if I were to be doing this one, I would find the right angle. And then measure it. Find the right angle, measure it. That gives me my new C. Here. That's 2, then I measure it. That becomes my new B. Then here for A, wherever it's a right angle, you measure it. And I'll give you your A prime. And then you do it again about the next line. So A to this line, that'd be A double prime. C down to this line. C double prime, then B down to this line. B double prime. And there's your new triangle, basically. And so, again, for a rotation, it's just about the 2 lines. For that intersect, for translation, it's about lines that are parallel. And so I think we should have a ruler with y'all, and so if you can measure it, the right angle, try to approximate, but if you can, try to get the measurements more precise for y'all. You can, again, all you gotta do is do the measurement and then do the same measurement on the other side. For a dilation, it's just by a factor, and so if they give you the dilation here, if they give you 6 as this side, 7 as that side, 3 as that side, they say dilate this by a factor of 4, and you're just gonna multiply each side by 4. And so my new figure then would have a side of 4 times 3 would be 12, 4 times 7 would be 28, and then 4 times 6 would be 24. And so it just increases the proportions by 4. If that would be an enlargement, if it's a reduction, then it's going to be a fraction less than 1. And so it would be 1/4. If it was like 1/4, then it would have shrunk it by 4. But this one was 4, so it enlarged it. If it's the same, if it's 1, then it's just going to be the same thing back. And so that should get you through those. The last things is symmetry. So remember, symmetry, line symmetry is basically where you can cut it and make the parts look the same, but it's just that way. You can't. But rotational symmetry is where you can cut it and basically spin it, and then every time you spin it, you get the same cut. So think of like a good one for illustration of rotational symmetry is like a starfish. A starfish you can cut, and basically every way you cut it, you can spin it and it gets the same cut back. So that would be rotational symmetry. Axis of symmetry, for the lines of symmetry are going to be angle bisectors, so it's going to cut the angles in half, and then you should be okay with that. The last thing is doing properties of isometries and actually using those. So again, it's basically where you have something like this. We have a ball here. Ball here. Basically, I want to see where I can bounce this one off of the rail to get to that other one. And so to do that, basically you're just going to extend it across and then reflect it. And so remember how we did that. Basically it comes down here. That's our line. And then we're looking for this part right there. And so you may need to go back through some of that. I'm not going to spend a ton of time on that. There's only like one problem on it, and we should be okay. But again, it's just reflecting it, and so the idea is that it's going to be the same distance and all, everything like that. And so that should be straightforward, I think, for y'all. Pretty much, if you have any questions, you should be okay, but you can contact me and I can kind of see what your issue is. So if you look at the test, basically 1 through 25 is the problems that deal with the true false. Then you have 26 through 28, which is actually doing the reflection of the quadrilateral. Then 20 through 31 is reflecting it twice, so a translation. 22 through 34 is the reflection. Those lines would intersect, so that's your rotation. 35 through 37 is the dilation. Then 38 through 40 is the one with the isometry principles. And so just think about that one. I don't really want to do too many of those because it would basically give you the answer. But on 38 through 40, they're basically wanting it to hit both of those rails. So instead of hitting the rail twice, it hits the rail twice. And so basically you're going to do it twice. You're going to do 2 reflections. So you're going to see where it would hit the rail the first time, and then where it would hit the rail the second time, and then you'd be okay. So try that. If you need help, again, contact me. I can see, maybe help you a little bit, get you pointed in the right direction. And then 41 through 45 are the symmetry ones. So try those. That is your test. So do well. Make sure you go back through the book for the definitions and all that if you need to. Have a good day.